Welcome. We're about to dive deep into T-SQL subqueries. You know, those handy little queries inside of other queries. We're going to see how to go from writing code that might silently fail to code that is fast, safe, and just professional. Let's jump right in.
So let's kick things off with a pretty standard business question. Seems simple enough, right? But to answer this, a basic select statement just won't cut it. This little puzzle is the perfect reason we need to have a more advanced tool in our SQL toolkit.
And that tool, of course, is the subquery. To get this problem solved, we first have to really get a handle on what a subquery is and, how it actually works. Let's break it down. At its very core, a subquery is exactly what it sounds like, a full select statement that you tuck inside another one. I always think of it like one of those Russian nesting dolls, but for data. It's a really powerful way to build multi-step logic into a single, clean statement. Now here's the absolute key to understanding them. The inner query, the subquery, it always runs first. It does its job, figures out a result, and then it literally hands that result off to the outer query. The outer query then uses that result to do its own filtering or comparing to get you the final data. But hey, subqueries are not a one-size-fits-all kind of deal. They come in a few different flavors. Sometimes you need one that returns just a single value. That's a scalar. Other times you need a whole list of values or even an entire temporary table. And then there's a special fourth type, the correlated subquery, which has some huge performance implications we really need to get into. All right, so we've got the basics down. Let's get our hands dirty with a new problem. But I gotta warn you, there is a really dangerous hidden trap waiting for us here. It's the kind of thing that can make your query fail silently, giving you totally wrong results without ever throwing an error. So here's the problem. It's a classic anti-join. Trying to find what's in one table but not in another. Super common task. And the most intuitive tool, the one you'd probably reach for first, is the not in operator. And this is the query most of us would write. I mean, it reads just like plain English, right? Get me the customers whether ID is not in the list of IDs from the orders table. It looks perfectly logical, makes total sense. But here's the shocker. When we actually run this query against our data, we get 0 rows. Nothing. Zilch. And this is even when we know, for a fact, that we have customers who have never, ever placed an order. So, what on earth just happened? Well, you just met the hidden pitfall. Our entire, perfectly logical query was completely defeated because the list of IDs from our subquery happened to contain a single null value. And this slide right here shows you exactly why. Not in just falls apart because of SQL's three-valued logic. You see, in SQL, a comparison isn't just true or false. It can also be unknown. And when not in tries to compare a customer's ID to that null in the list, the result isn't false, it's unknown. And that one unknown result poisons the well, causing the whole condition to fail for every single customer. On the other hand, the safe alternative, not exists, just does a simple true or false check for a match. It's completely immune to this whole null problem. So the big takeaway from the experts is this. For code that you can actually trust in production, you really should just stop using not in for these kinds of anti-joins. The professional, safe, and reliable way to do it is with not exists. It gets the same job done, but without that hidden null trap. Okay, we've dealt with safety. Now let's talk about speed. It's time to dig into that other type of subquery, the correlated one, which can bring your database performance to its knees if you're not careful. Let's circle back to our very first question, finding those high-earning employees. A really common way to solve this is with a correlated subquery. You can see the key right there on the screen. The inner query is actually referencing a column from the outer query. This creates a direct dependency between them. And that little dependency? It creates a massive performance trap. Because the inner query depends on the outer one, the database has absolutely no choice but to execute it over and over and over again, once for every single row in that outer table. Seriously, think about that. If you've got 1 million employees in your table, that little inner query is going to run 1 million times. This row-by-row processing is the exact opposite of how SQL is designed to work efficiently. Modern set-based patterns, which we're about to see, are just dramatically faster because they process all the data in one go. So, if correlated subqueries are slow and not in is unsafe, how do we solve these problems like an expert? Well, we use modern T-SQL patterns that are built from the ground up for performance, safety, and frankly, readability. For our salary problem, the best-in-class solution is a window function. Just look at that over partition by department clause. You can think of it as telling SQL, hey, for each department, create a little window, calculate the average salary just once for that group, and then stamp that average onto every employee row in that department. It does all of this in one single, super efficient pass over the data. No more row-by-row nightmare.
And for even more complex situations where you really do need to connect rows, like finding the top 5 orders for each customer, T-SQL gives us the apply operator. Think of apply as the highly optimized, smarter big brother to the correlated subquery. It's built specifically for these kinds of tasks, and it's far more flexible and efficient.
So here it is, your key takeaway. This is the cheat sheet you want to burn into your memory. Need to check if something exists? Use exists. Need to find what doesn't exist? Use not exists to stay safe from those nulls. Got a tricky top n per group problem? Apply is your best friend. And for those per row calculations, reach for a high-performance window function every time.
And that really leaves us with one final crucial thought. Look, getting a query to run and spit out some data is just the first step. The real mark of a pro is writing code that isn't just correct, but is also safe, totally reliable, and lightning fast. Mastering these modern patterns? Well, that's what's going to get you there.